Welcome everybody in AP Chemistry series. Today we start with part 2 of section 8.4, which is all about acid-base reactions and buffer. Today we're going to calculate the pH after combining an acid with base. As you just remember, if we have two solutions, okay, one of them is acidic, one of them is basic. If we mix them together, what will be the pH after combining these two solutions together? And since we're given an acid and a base with their molarities and their volumes, we have to apply the Voom thing. So what's Voom thing? Since we're adding two solutions to each other, we're going to calculate their new molarity. We have to make a small table first. All right, so here we have the perchloric acid HClO4. It has a volume of 35 milliliters with 0.2 molar, but for potassium hydroxide, we talk 25 milliliter with 0.25 molar. Now, if we apply the Voom thing, we're going to calculate the molarity after dilution process. So how can I do that? Let's start with HClO4. We're going to calculate the M2, which is the one that I need. So the first part we have to say, we took 35 milliliter of perchloric acid. We multiply by the molarity. The total volume becomes 35 plus 25 since we're adding two volumes in here. Okay, and then we multiply them with the new molarity. If we apply math, if we divide this over the total of 60 milliliter, since the summation of these is equal to 60, you will end up with a new molarity of acid, which is 0.1167. So I have to put this in here, 0.1167. And if we apply the same procedure for potassium hydroxide, we are going to apply like 25 milliliter. It's multiplied by 0.25. And the summation of the two solution is 60 milliliter multiplied by M2. We divide over 60, and here we divide over 60. Then the new molarity of KOH is equal to 0.1042. So this is the answer in here. Okay, now we have two concentrations that we're going to use in our calculations to calculate the pH at the end. So how can I do that? All right, the next step is writing the net ionic equation. And since we have a strong acid and a strong base, their net ionic equation is always H positive plus OH negative and gives only water. Okay. Now, what is the concentration of acid? It was 0.1167, and the concentration of OH is equal to 0.1042. If you watch the previous video, we said if we have equal number of H positive and OH, you will end up with the same number of water. If you have 5 in here, you will end up with 5 water molecules. So here we have equal amounts of H positive and OH. But what happens if you have an equal number of H positive and OH? And this is actually what happens in here. Which of these two materials, like the base or the acid, is the limiting reactant? The limiting reactant is a substance that is consumed up first during the reaction. In other words, the little amount. So we can notice that the OH is in a little amount in that point. So since they're reacting, we have to subtract 0.1042 because it will be totally reacting with H positive. We're going to subtract 0.104. Okay. At the end, you will end up with zero amount of OH, but you still have extra amount of the H positive, which is 0.1025. So this is the same thing as we said. For example, if you have 9 H positive and you have OH that is 7, for example, at the end you will end up with 7 water plus acidic, or let's say 2 H positive. And at that point we have extra acidic. Okay. Now my question is how to calculate the pH of the solution. We just noticed that we have only H positive that dissolves in water. We don't have any conjugate acids We don't have any conjugate bases. We don't have any weak thing. So in other words, we have only H positive as a species. So in order to calculate the pH, we just take the negative log of the H positive, which is hydronium ion. And if you apply in your calculator 0.0125, this is the remaining concentration of H positive, and the pH is going to be 1.903. So this is the pH of your solution. Now, what if we have reverse amount of OH and H positive? What was going to be the pH? So we're going to do the same procedure first. And suppose that we have 0.1042, but for the OH is 0.1167. At that point, what is that limiting reactant? It's H positive. Then I have to subtract the other guys from this limiting reactant. Okay, they have to say 0.1042. The remaining amount of H positive is 0 because it's totally consumed up. But for the OH negative, 0.0125. In order to calculate the pH, we have to calculate the pH first, since we have OH at the point. So the pH is equal to negative log 0.0125. And since the answer is 1.903, then how can I calculate the pH? If your question is done at 25 degrees Celsius, we can consider that the pKw is equal to 14. Then I have to say it's 14 minus 1.903. And if you apply that, it is equal to 12.09. So we just notice that the extra OH that dissolves in water only gives a basic medium. But if the remaining is acidic, then it's going to be acidic medium.